Let's talk about metallurgy on Mars. For anything other than base metals like iron or aluminum, we don't know exact locations of the ores. Where lead or copper concentrations are located, we have only some approximate idea. It's all doable in terms of we can find and start, digging for the ore, but it still has to be done. Another thing that has to be addressed when doing anything metallurgical on Mars is the lack of any reducing agents available immediately. You need either hydrogen or carbon monoxide or electricity to smelt, any metal pretty much from oxides, or carbonates. For some things, some of them it's relatively straightforward. For some of them, a more advanced, chemistry is required. For aluminum, for example, you can't just electrolyze alumina. You have to first dissolve it into the cryolite fluoride mineral, which lowers the melting point of the electrolysis process. And that you have to be either manufacturing on Mars or importing from Earth. If we go into more sophisticated alloys, we would need a lot of extra metals like molybdenum or tungsten or lithium or magnesium, and all of them require, quite a lot of field geology to discover the deposits. And just as with previous metals, you need reducing agents like electricity or carbon or hydrogen to extract the ore to extract the metal from the ore. For titanium, for example, you need to reduce it with magnesium, and magnesium you have to reduce it with its own process, usually electricity. So all of this presents a long list of challenges. None of them are fundamentally unsolvable, but all of them require thorough, detailed solution, starting with locating the ore deposits, and developing the Mars-specific metallurgical process, which takes into account availability or lack of specific chemicals, resources, or environment conditions.